Today, what we're going to be doing is working with some inequalities and basic inequalities. So the first activity is just understanding what an inequality is. So here it says work with a partner, so we'll be doing this together. Read the statement, circle each number that makes the statement true, and then answer the questions. You are in at least 5 of the photos. So you have all of these photos and you're in at least 5 of the photos. So the first question says, what do you notice about the numbers that you circled? So we're going to go through and circle the possible answers. So if we're in at least 5 of the photos, well, that means we would be in 5 or any number that's bigger than 5. So it could be 6 and so on, okay? So it says, what do you notice about the numbers? Well, when you look at the numbers that we circled, they could be 5 or higher. Or you could use the word greater or larger. Okay, so we noticed that we circled the numbers 5 or higher. Is the number 5 included? Yes. Why is it included? Because we were in at least 5 photos, but it could be more than 5. Okay, so I'm not gonna write that all out. I'm just gonna verbally explain that. Write 4 of the numbers that make the statement true. So we've already circled 5 and 6. What are 4 other numbers other than 5 and 6? Well, we could do 7, 8, 9, and 10. And you wouldn't have to use those 4 numbers. Those are just the next 4. You could use any number that's greater than 5. Okay, so let's go ahead and look at our next one. Actually, we'll shift this over here. All right, letter B, it says the temperature is less than -4 degrees Fahrenheit. So could that include -4? No, because it's less than -4 or colder than -4. So colder or less than would be -5, -6, -7, and then working our way down this way. What do you notice about the numbers that you circled? Well, they are all less than -4. Okay. Can the temperature be exactly -4 degrees Fahrenheit? Explain. Well, it said that it was less than -4, so this would be a no. We could not include -4. Why? Because it was less than 4. Sorry, -4. So it is not including -4. Write 4 other numbers that make the statement true. So other numbers other than the ones that we circled up there. Well, if we were to continue our pattern, we could do -8, -9, -10, -11, and so forth. You don't have to use those 4. Those are just the next 4 ones that if we were to continue the pattern. All right, letter C. More than 3 students from our school are in the chess tournament. So could that include 3? No, because that's more than 3. So we know any number that's more than 3. So here's the options that are given to us. What do you notice about the numbers that you circled? Well, they're greater than 3. Is the number 3 included? No. Why? Well, why wasn't it included? Because there were more than 3. Okay. Write 4 other numbers that make the statement true. So we've circled 4, 5, and 6. So 4 other numbers, 7, 8, 9, 10. You could put any number that's greater than 10 even. Okay, so I want you guys to go ahead and you will work through letter D on your own, and then you can check that off of the answer key for activity 1. All right, we're going to go ahead and transition into activity 2. Okay, so activity 2 is understanding inequality symbols. It says, consider the statement, x is a number such that x, that means is greater than, negative 1.5. So one thing, I know that students sometimes get confused by these symbols. So another thing you can think of is that symbol is eating the x, which is the bigger number. If you got to pick a pile of cookies, you would want the bigger amount of cookies if you like cookies. Okay, so x is bigger than or greater than negative 1.5. Can the number be exactly negative 1.5? Well, no. Why? Because x has to be bigger or greater than negative 1.5. Okay, it says make a number line, shade the part of the number line that shows the numbers that make the statement true. Okay, so a number line, let's see. We need to have 1.5 on there. So I'll do negative 1.5, maybe 3. And and that's a negative 3, sorry. We'll do a positive 1.5 and a positive 3. So as long as you've got your numbers in the right order, it really doesn't matter which numbers you choose to put on your number line. Okay, so if I were to graph this and shade anything, shade the part of the number line that shows the numbers that make the statement true. So x has to be bigger than or greater than 1.5. So numbers that are greater than 1.5 would be like any of these, right? 0 is greater than negative 1.5. 1.5 is greater than negative 1.5. 3 is greater than 1.5. So it's really any of these that are falling this direction. Okay, and we could have any number on there, but it's any of those numbers that are to the right of that negative 1.5. It says write 4 other numbers that are not integers that make the statement true. So not integers is the key thing there. Integers are going to be whole numbers or negative whole numbers. Okay, so we can't use the 3 there, but we can use any decimal. So numbers that are greater than negative 1.5, negative 1.2, negative 1.1. We could do negative 0.9 or 0.9, negative 0.8. Okay, those are all numbers that are integers, that are not integers, sorry, and they're greater than negative 1.5. Because if I were to plot those, they would fall into this category right here, falling between that negative 1.5 and that 0 mark. Now, you could put positive numbers too. Those are just the ones that I chose to do. All right, let's go ahead and look at B. Consider the statement, x is a number such that x is less than or equal to 5/2. Okay, so we're working fractions this time, and I know sometimes working a fraction and having to set up a number line is kind of confusing, but we're going to go ahead and work through it together. Okay, so looking at our symbol, the 5/2 or the 5/2 is the bigger number, which means x has to be smaller. Okay. Can the number be exactly 5/2? Yes. How do we know that? Well, this symbol is less than or equal to. That little line underneath of there means the equal to. So yes, it could be. Okay, so yes, we could include that. Make a number line and shade the part of the number line that shows the numbers that make the statement true. So number line. And I'm just going to put 5/2 here. And we could do 6/2, which is the same as 3. And we could do 4/2 on this side, which is the same as 2. Maybe 3/2. 2/2 is the same as 1. We could do a half. Okay, and then we could do, let's see, 3 with 6/2. We could do 7/2. Okay, and you wouldn't have to use halves, those are just the ones I chose. Now they wanted us to shade the part of the number line that shows the numbers that make the statement true. So X is less than or equal to 5 halves. So that could include 5 halves. Less than 5 halves would fall this direction. So 2 would be less than 5 halves, 3 over 2, 1 half, anything that is falling to the left of that point. It says write 4 other numbers, once again, that are not integers. So we don't want the whole number ones. So I'm not going to include this one or that one. So that make the statement true. So other than 5 over 2, other numbers, well, we have 3 over 2 that I have on my number line, and I have 1 over 2. We could do negatives of each of those, negative 1 half and negative 3 over 2. You could even do like 1/4, 1/8, 1/16. Just depends on your comfort level with fractions. So that's it for activity 2. Okay, so you'll have to move into activity 3, which I'm doing as a separate video. So good luck with this. Once again, the only thing that you needed to do independently was to finish off activity 1, and then you can check your answers with the answer key.